Hello, everyone. It's the Prophet Michael David, aka Aries, and I hope everyone's having a great day. Last few days of spring. So I'm dressed up because tomorrow I'm going to go and talk to the mathematicians at the university about my stuff, and so I'm going to dress exactly like this. You know, presentation does mean something in this universe. But today, you guys are like my dry run. I'm going to do 2 videos about my mathematical miracles and stuff, and they're going to be in order. So the first one, this one, is going to be on the twin prime conjecture, and the next one's going to be on the Kautz conjecture. Okay, so I've come up with like a standardized structure. I made a folder with a bunch of screenshots and everything that I could use to basically explain in a video like this or to any other person. So I got the standardized process, and that's what we're going to do right now. So here we go. So that is the video you should pause this video and watch before you watch the rest of this video, so you know exactly what I am claiming to have proved. And I'm going to do in spreadsheets and just basically show you my equations so you can do it yourself. Plus, I'll explain some stuff. Again, as full disclosure or proof of concept or whatever, that's the folder that I'm using to explain all this stuff to you or anybody that asks me about it. Okay, we're going to start slow here, but I promise it'll pick up. So basically, my expertise is that most mathematicians ever think of, and this is the analogy that I use these days, think of mathematics as being one long infinite string. Think of like a one stringed lute. And they've found all these different techniques to play all these different songs on this one stringed lute. And but there's some stuff that they just haven't ever been able to play. So again, metaphorically speaking, all I did was I took that one string lute, and I'm the guy that invented the 6 string guitar. This is all about uh, looking at numbers in different bases, different modulus lines. Modulus lines are just a different way of looking at algebra, but that's where we start. Okay, so we use base 10 for our number system, and I will give you 10 guesses why, but you should only really need one. But you can look at the numbers in different base systems. But that I've just showed you is base 10 using the way that I look at numbers. Okay, the greens and the blues are all primes, and the pink ones are prime squares. Um, and why I did the greens and the blues will be self-evident in a second. But again, the greens and the blues are all primes, and the pinks are prime squares, and that's how they're distributed in base 10. That's why they always say, except for 5, you know, all primes end in a 1, 3, 7, or 9. That is how I see primes. That is base 6, aka mod 6 or modulus 6. And as you can see, why I colored them the way I did is because all of the blue ones, when you do analysis this way, all the blue ones are 5 mod 6 primes, and all the green ones are 1 mod 6 primes, aka 7 mod 6 primes, which I'm going to try to keep consistent from this way on. So 5 mod 6 primes and 7 mod 6 primes. It's like sky and the ground or heavens and the earth, you know. 5 mod 6 primes are blue and 7 mod 6 primes are green. And again, the pink ones are primes squared. So it doesn't matter if the primes are on the 5 mod 6 line or the 7 mod 6 line, their square is always on the 7 mod 6 line, which brings us to the next point. So long ago, I found this equation, which I called x numbers, hence the xn, where I found that all prime square values in this equation were a whole number. And so I called them x numbers. But all I was really doing was I was indexing the prime squares and finding out what nth number they were on the 1 mod 7 mod 6 line in this case. So again, look at the mod 6 basics thing you just saw before and everything. And all when you do prime squared minus 1 divided by 6 is you're finding what nth number it is on that mod line. So for instance, 5 squared is 25. So the first number on the 7 mod 6 line is 7, plus 6 is 13, plus 6 is 19, plus 6 is 45. So the 25 is the fourth number on the 1 mod 6 line, and that's why its x number is 4. Second one, 7 squared is 49. 49 minus 1 is 48, divided by 6 is 8. Okay, and so if 25 is the fourth, then you got 31, 37, 43, 49. 49 is the eighth number on the 7 mod 6 line. So all you're doing with that equation is you're finding out what nth number that you are on the 7 mod 6 line. Okay, so I know this is remedial for a whole lot of you, but again, we're starting bare bones here for people that don't deal with spreadsheets a lot. Again, I'm using Apple's numbers, but these equations should be the same for Excel or any other spreadsheets, or very, very similar. So in the screenshot you just saw, it's empty screenshot except for the numbers on the top. I'm going to show you guys how to develop those numbers. Okay, for the first one, the x-axis, you type in 1, and then that's the equation you use. Remember, those dollar signs are save column or save row. So in this instance, it's a saving row. Same thing in the y column. Type in 1 on the first one, and then in number 2, you put in that equation, and it's save column instead of save row. And then you type that equation in A1 times B1, and you drag it out, and that's how you make a times table. Again, I know this is insanely remedial to some of you, but there are some people in the future that are going to see this video that really have no interactions with spreadsheets, so this will help them much. So then, like, looking at the times table, I started to see some of my X numbers on there, like 4, 8, 20, 28. And so I decided to do the opposite. And if the X numbers were represented on the times table, then that equation you just saw would turn them back into the primes, which they originally were. So I'm just modifying the times table because a lot of the elements represent those X numbers, the position on the 7 mod 6 line. So if you copy your times table, change it to something else, and then do that modification by calling from the first times table, you will find that it transforms your numbers into that. Yes, there are some whole numbers. A lot of them look to be primes. Some are squares, and there are some composites, but the rest of them have decimals. So now we just want to get rid of the decimals. So this is another trick I use in spreadsheets is I use if statements and floor functions. I actually used the if statement in the last one too. I just didn't explain it as much, although the equations work. So what a floor function is it means always round down. 5.1 round down, 5.9 round down. Opposite is ceiling function, and there's a round function too. But I always use floor functions. And the reason I use them is because you can do an if statement with the floor function, and if the floor function and the thing that is floor function is the same, then return something because they'll be exactly equal. That minus that is 0. But if it's not, it means it has a decimal. So then do something else. So that's all I did in this equation is floor function. If it's a whole number, then display the whole number. And if it has a decimal on it, display a 0. So then I just started coloring in a small portion of the graph in exactly the same colors that I use for everything else. So the blue ones are 5 mod 6, the green ones are 7 mod 6, and the pink ones are squares of primes. So then I just decided to color only the inner two lines, the mirror image, the lines that I saw first, and that's what I did. And then this next graph is going to be like blown out all the way to the end of the 6 mod 6 thing to 121. So if you aren't all excited yet, how does this solve the twin prime conjecture? Is because I took this information isn't coming from the actual primes themselves. It's coming from the prime squares. Um, as I've said before, area imparts information where magnitude just imparts signals. It's the same reason why a black hole is ultimately defined by its surface area of its event horizon. In other words, Euclid, like 2,500 years ago, proved that there are an infinite amount of prime numbers. He uses primorials. It's actually really, really cool. You should look it up. But I had Google AI. You can prove that there are an infinite number of 5 mod 6 primes and 7 mod 6 primes using a similar example. So this is what the Google AI came up with. She did a really good job. So, in conclusion, for this first video of the day, twin prime conjecture solution. So we're taking basically information from the primes that are normally in a single line magnitude, and we're modifying the times table to represent them in 2 dimensions. And so all those squares of primes, they're on one line in the mod 6 screenshot, are now in a bunch of different places, but they're segregated back into the 5 mod 6 and 7 mod 6 lines when you do it in 2 dimensions. And it shows that Euclid showed there's an infinite amount of primes, and the one I just showed you showed that the 5 mod 6 and 7 mod 6 lines have an infinite amount of primes. And so you can't have it both ways. If the statistical chance of any number that ends in 1, 3, 7, or 9 being odd is prime is 0, then you will have those positions come up infinitely often. And to prove it, or to prove like mastery of this, is that it shows that prime numbers will always go from 5 mod 6 to 7 mod 6. Cousin primes, 4 spaces of 4, will always go from 7 mod 6 to 5 mod 6. And then sexy primes, spacings of 6, will always go from 5 mod 6 to 5 mod 6 or 7 mod 6 to 7 mod 6, but never. And then the pattern just repeats again. So, like for you guys on the know about the Z10 Zhang, if there is a spacing of exactly 70 million between primes that happens an infinite amount of times, I know it's in between, but if there's exactly that 70 million, then you know for a fact that the spacing has to go from a 7 mod 6 to a 5 mod 6, because 70 million is divisible by 10, and then 10 minus 6 is 4, and the spacing for 4 mod 6 is always from 7 mod 6 to 5 mod 6. It's just a repeating pattern over and over and over. And it has to happen infinitely often for all of them. So it's not just the twin prime conjecture. It also proves that all spacings are infinite, like James Maynard talked about in the video that you should have watched before this. And so it proves that as well. And what it also proves is, because there's the maximum density, that you will have not just an infinite amount of twin primes, but you will have an infinite amount of twin primes that the first twin prime starts with 1 and is a 5 mod 6 prime. The second prime starts with 3 and is a 7 mod 6 prime. There's a 5 odd number that ends with 5, so it isn't prime, And then the next number is the next set of twin primes. It's a 5 mod 6 number that starts with 7, and it is the last one is a 7 mod 6 number that ends with 9. It's like 5 guitar strings, and in 5 sets of odd numbers, 5 guitar strings, the one in the middle, the 5, is the only one that isn't prime. So 4 out of 5 odd numbers will be prime, no matter how big the primes or the number set gets. All right, this is that for this video. I think I'm going to do my Collets one next, and so I hope you like the outfit. I worked really hard at this video, kind of like back in the day. If you didn't totally understand it, don't worry. When I say I try to dumb this down, it's for actual people that call themselves professional mathematicians. And honestly, I'm not using a whole lot of hieroglyphics like they do. And I try to use a lot of metaphors. So anyway, signing off for this video. As always, rule number 1, do not touch other people without their consent, aka do not hurt each other. And rule number 2, it's all about honesty. Lies are a takedown, aka try not to lie. All right, I love you all very much. I will talk to you here very shortly.